So how do those atoms get stuck together? It's not super glue or anything. They're held together by chemical bonds. We're going to talk a lot more about chemical bonds in a later chapter. For now, we're just going to tell you as what you need to know so that we can learn some chemistry. So chemical bonds result from attractions between oppositely charged particles. We mentioned that electrical charge is a property of a substance, and there's an attraction between opposite charges. Inside atoms, we have electrons and protons. Electrons are negative, protons are positive, and so we have charged particles and we can have attractions between them. We can divide chemical bonds into two broad categories, ionic bonds and covalent bonds. So ionic bonds, as the name suggests, involve ions. Ionic bonds are going to occur between metals and nonmetals. We mentioned on Monday that metals tend to lose electrons and become positive cations. Nonmetals gain electrons and form negative anions. We have oppositely charged ions, and the attraction between those charges is an ionic bond. Ionic compounds tend to have very high melting points, so they are generally solids at room temperature. And if we look at the solid phase of an ionic compound, it has a definite pattern. It's composed of a three-dimensional lattice. So there's a three-dimensional array of alternating cations and anions. Ionic compounds do not have molecules. A molecule like water, one oxygen atom, two hydrogen atoms, it's an individual particle, right? In an ionic compound, a solid piece of that compound is going to be just continuously alternating cations and anions, and they are all attracted to each other. There aren't really any individual particles. Here we have illustrations. Here's sodium metal, all the same atoms, all sodium atoms. It's an element. Here we have chlorine gas. All of these particles are the same as each other. There's only one kind of little sphere. They're all chlorine. And so when these two things combine, a metal and a nonmetal, the metal, neutral sodium, will tend to lose one electron. The electron has to go somewhere. So the electron goes to the chlorine atom. The neutral sodium becomes a positively charged ion because it lost an electron. The chlorine becomes a negatively charged ion because it gained that electron. Now we have oppositely charged particles, and they are attracted to each other because of their electrical charge. And so they will stick together much like magnets do, and they will arrange themselves alternating cation, anion, all the way through in all three dimensions. They do that to maximize their attractions and minimize repulsions. Because if two of these chlorine ions get too close to each other, they have the same charge, they're going to repel each other. And so it's just maximizing attractions, minimizing repulsions, and it will just form this sort of an array all the time, every time. Any questions? This is another illustration of how the properties of a compound are very different than the properties of the elements. Sodium is a metal, and it's actually a rather soft metal. You could take a table knife and cut it. It's also very reactive. If you put a small piece of this in some water, it will fizz and generate hydrogen gas in a little explosion. If you put a big chunk in water, it will explode. Very dangerous. You wouldn't want to eat sodium, right? Chlorine gas is toxic. Breathe much of that and it will kill you. And yet you combine these two things together, you get sodium chloride, and if you have no sodium chloride in your diet, you will die because your body needs sodium chloride. Of course, if you get too much, you'll also die, right? So, we think of things, this is toxic and that's safe. Well, is anything really safe? You need water to live, right? Drink too much water, you'll die. Need oxygen to live. Breathe too much oxygen, you'll die. So it's all, amounts, right? Moderation in all things. So those were ionic bonds. Covalent bonds. This prefix co means sharing. So this is a sharing of valence electrons. So covalent bonds are going to happen between two or more nonmetals. We're not going to form ionic bonds between nonmetals because they both want to be negative, and they can't agree on who's going to be negative and who's going to be positive, and so they don't do it. These involve sharing electrons. So here's an illustration of this. Here we have, these would be the positive nuclei of two atoms, and here's an electron that they're sharing. They're both attracted to the shared electron. When the electron is over here on the side, this is not a very stable situation. Or when the electron is over here, the most stable situation is where that shared electron is going to be between those two atoms. They are both going to be close to it, and that's the most stable thing. And so this is going to be a covalent bond. The shared electron holds those two atoms together. We call covalently bonded compounds molecular compounds because they have molecules, unlike ionic compounds that have individual ions but do not have molecules. Any questions?